This is the Mechanics Homework Booklet, question 20. The diagram shows a speed-time graph for a car that halts at traffic lights and then moves away. You should spend a little bit of time looking at the graph before rushing ahead to see what the question is. So make sense of what you can see. So we have a speed-time graph. The car halts at traffic lights and moves away. So clearly this middle section is the point at which the car has halted at the traffic lights. And we can see a deceleration approaching the traffic lights and an acceleration when leaving the traffic lights. You are asked to use the graph to show that the car travels about 380 metres whilst decelerating. So that corresponds to this section of the graph. Now, you have to be aware that the question is asking you to use the graph. It's also using the phrase to show. That should make you aware that the examiner is likely to expect to see your method. And you may lose marks even for a perfect final answer if you don't do that. So here it is worth stating that the distance travelled is equal to the area under the graph. In this mark scheme, it was a separate, distinct marking point to say this. So we're working out the area of the pink shaded triangle. So we have got half of the base here times the height. And worth checking when looking at the height that the axes did start at 0. Careful manipulation then of your numbers leads you to an answer of 375 metres. Part B. Again, you're asked to use the graph, and you are asked to find the acceleration of the car for the time interval from 75 to 95 seconds. Here on the mark scheme there was a method mark. That means that the final answer is worth nothing without previous evidence showing this stage. So using a speed-time graph to find acceleration, we would be finding the gradient, or you could state the equation for acceleration. So the gradient of this graph for the acceleration section is equal to the change in speed, which is final minus initial, so 30 take away 0, divided by the time taken for that change, which is a time interval of 20 seconds. Substituting that into the equation leads you to an answer of 1.5 metres per second squared. Part C, you're asked to calculate the total distance travelled by the car in the interval 5 to 95 seconds. So you could think back to the 3 stages that the graph showed. The graph showed the first stage of deceleration starting at 5. Notice that matches what we have in the question here. Then there was a middle stage where the car wasn't moving, and a final stage ending at 95 where the car was accelerating. Now we've actually already worked out in part A the distance travelled whilst decelerating. So we just need to add the distance travelled whilst accelerating in the final stage. So again we have area of a triangle. It was the same change in velocity, so the same change in height, but the time interval for this last stage was shorter, only 20 seconds. So working out those 2 areas and adding them together gives us an answer of 675 metres. Do be careful if ever you have a simple line like this for your answer with no unit provided. It is your job to put in the unit, and you're likely to lose marks if you don't do this. Finally, you're told that a second car travels the same route but without being halted at the traffic lights, and this car maintains a constant speed of 30 metres per second. You are asked to calculate the difference in journey time between the first and second cars. If you were thinking back to the graph and what that would mean in practice here, that would be a car that just manages to give you a straight line across here for its graph. So, thinking about how you could find the difference in journey time. We're going to compare the journey from 5 to 95 seconds. The reason I've picked those values is that before and after this, both vehicles were travelling at 30 metres per second, so that would give no difference in their journey times. So this is the significant part of the graph to study. If the car was travelling at constant speed, then the time taken for this journey would be the distance divided by the speed. We have worked out the distance corresponding to that journey in the previous part of the question, so we substitute 675 divided by 30 to calculate the time. That gives us an answer of 22.5 seconds had the car maintained 30 metres per second. However, we can read from the graph or think about the values given for time between 5 and 95 seconds and see that car 1 took 90 seconds to cover the same distance. So quite simply then, the difference in the times is the 90 minus the 22.5, giving us 67.5 seconds.